All right, welcome back to the study hall. Last one of the year. We're going to do some miscellaneous word problems on the quant side of things. So again, the problems that are in this presentation are the property of GMAC, although they are all in the software that is approved for free distribution. So there's your copyright notice. Okay, let's do one. Okay, people are moving things, so whiteboard privilege is gone. All right, let's go ahead and do a problem. How about that one? Remember where your multiple choice answers are found. They are found right there underneath your name. Check it out. So for a problem like this, it's okay to take a little bit longer than average, but if you are, at this point in the game, if you are not definitely doing something that is directed towards a definite goal that is definite, then you should probably just pick an answer choice. But so how many of you guys 20 or 30 more seconds to pick something here? So then we will discuss. Okay, let's take a look. We are all over the place on this one. What's interesting, I don't normally show the distribution of answers that people pick because there's not much of a reason to show it, but here's the class choices. There's this weird spike at, this is actually not the right answer to the question, so that's what's interesting about it. But there was one point where there were 8 responses tallied and 6 of them were B. It's kind of strange, but the answer is not B, guys. I don't know what is the magnetic draw of choice B, but no, it's not B, but let's see how this works. So yeah, so obviously this is a very challenging problem. The question is, what makes this challenging? Like when word problems are hard, why are they hard? Sounds like a dumb question at heart, but it's really not. Why are they hard when they are hard? What do you guys think? Ideas? Chat box. So when you say tricky, what do you mean by tricky? I mean, it's definitely something about translating the words, but when you say tricky, if you might mean one of many things when you say that. Because tricky sounds like it means that the writers of the problem are purposely writing the words in a way that foments confusion, which, if anybody is thinking that, by the way, that's definitely not a thing. Like one thing about this test, and the official problems at least, is that there is not any intentional trickiness in any of the problems. Like it's sometimes they have a lot of words that are sort of awkward, but that's, as we're going to see, that's an artifact of what happens when you try to put math into words. But just make sure that you realize that they're not purposely going out there like, I'm going to trick the test taker. They don't do that. In fact, in just about every case, the problems are essentially always written in the most efficient way possible. And they're still weird, but it's not the fault of the test writers. The fault is in the whole sense of math written in paragraphs. So There's no tricks in the wording. Just make sure you're aware of that. I mean, because it is just kind of cumbersome. But the problem is this. The problem is math in paragraphs is inherently a problem, and there's not really a lot that you can do to make it less of a problem. Like thought experiment, if you follow a sports team, you're probably used to seeing tables of standings in the league. You know, wins column, losses column, and it's very easy to find a team in a table of standings and to see how your team is doing relative to other teams. Now take that same situation and imagine that the same information was in paragraphs. It wouldn't be any harder to understand, but it would take a lot longer. I mean, the information you would normally find in 2 or 3 seconds might take half a minute, which is about 10 times as long. And just that simple act of transmuting columns into paragraphs would literally make it like tenfold longer to understand the same stuff. So the paragraphs themselves are a problem. So the question is, how do we deal with math in paragraphs? Well, because I mean, a lot of things that are math-ish are also in paragraphs in the real world. Like if you do taxes for some business, the tax code is written in paragraphs too. But what people do in the real world to make this easier for themselves is what people do to make this easier for themselves is they separate out the task of understanding the paragraph from the task of everything else. That's the key, is to separate 2 tasks, which are, number 1, get the stuff out of the paragraph, and number 2, do the math. You should separate these things. This is the point. And to this end, I mean, people do this a lot in the real world for various tasks. For example, people make spreadsheets for stuff. Probably everyone watching this session has made a spreadsheet at some point in his or her life. Genius observation of the day. When people make spreadsheets, the spreadsheets are empty at first. People don't make half a spreadsheet and then fill it in with stuff and then try to write formulas that involve the other half of the spreadsheet that's not there yet. People don't do that. But then the stuff that people do when there are word problems sort of resembles making like half a spreadsheet or not even making a spreadsheet and then just trying to like do stuff. It's a lot harder. So to this extent, what we want to do to make our lives easier here is we want to not do any math until we have everything pulled out of the paragraph. So that means we need to do 2 things. We need to physically organize, and then we need to get the information out of the problem before we start doing any math on the problem. So the point is, after we do these 2 tasks, and if we do a good enough job of these, we should only have to go through the paragraph once or twice. After we do these things, we should not have to look back at the paragraph, ever. And that's a good sign of whether you are organized enough in your approach to this, is after you do those red things, but before you do any math, in fact, before you even choose how you're going to do the math, you should have everything out of the paragraph already. Then, and only then, pick a strategy. Try it. If it doesn't work, try another strategy. That's the point there. So let's see how that works out here. So let's just get all this stuff out of the problem. And the more stuff there is in the problem, the more crucial it's going to be to do this. Because we basically had an entire class that was basically just guessing on this problem. So let's just take a look. Let's just go through and see what's in it. So physically organized, meaning a list, chart, whatever. I mean, if you're going to make an empty spreadsheet for something, then that means I just need to find all the things that are in the problem. So things that would be headings of a chart or a list or a spreadsheet or a something. So let's just go through it and see what we have and just see how to organize it. It doesn't have to be any crazy genius organizational scheme. And I'm going to take these and make them a little bit less bulky. Okay, you'll see that same graphic that I just got rid of. It'll show back up on your screen in a second in a smaller size. Okay. All right, so let's do the physically organized thing. Let's just see what is going on in the problem, see what things are in it, and then just pull them out and put them in some sort of chart. See how that goes. Okay, so well, let's just go through the problem line by line, see what's in it. So this year, there's going to be an amount saved and an amount spent. So we got those. This year, he will save an amount. Notice that's an amount, not a fraction or anything like that. And then next year, so this is new, there's no income next year at all. But notice the dollars that he saves this year we've already accounted for, so we don't need to account for those again. But available to spend next year is a new thing. So that's going to be, I mean, obviously you don't have colored markers to use when you take the test, but just to promote understanding of what we're doing here. So next year there's an amount available. There's not going to be income saved or income spent next year because there's no income next year. And then we have a fraction of income. That's back to this year again. So notice that that is amount saved, and there's also fraction saved and amount spent. So those are all related to each other, but now that we know that all of those are going on in the problem, then we can deal with them more effectively. So if we were trying to do math at the same time as this, it would just get really crazy really fast. That's why when you guys are writing in the chat box, it's hard to translate into math terms. Now you see why, because you don't even know what things are going to be in there yet if you try to write equations too early. And then next year, the amount that he has available to spend, we already got that. This is not new. And then the amount that he spends this year is not new either. So there's really not that many things in the problem, now that we think about it. I mean, it looks really intimidating, but honestly, it's really not that bad. It's only terrible when you start trying to do math when you are 2 lines into it and you don't really know what's going on. Yeah, that's when it's bad. Okay, these are all the things that we have. So really, we don't need to be really fancy about this. There's really no way to even make things like rows and columns because we don't have any of the same quantities for this year or for next year. So I'm just going to make a list. Let's just do that. So this year, and we have income, total, we have a total income. We have a fraction saved. We have an amount spent. We have an amount saved. We have an amount spent. And then next year, we just have an amount available, and that's, in fact, that is all we have for next year, is an amount available. And that's it. All right, that's everything in the problem. It's kind of relieving to know that giant paragraph doesn't have anything else waiting for us, but this is everything. Okay. How about that? Now, what we do is we pull all the stuff out of the problem, including math relationships. So when we say get everything out of the problem, we're talking about 3 different kinds of things. we're talking about, I mean, if anything is an actual numerical value, then obviously, like if they said that he makes $50,000 this year. So nothing in this problem is a numerical value, but if you had any numerical values, then you would definitely want to get those out. But also relationships among quantities that are in the problem. I mean, these are the things, if you were actually making a literal spreadsheet here, then these would be like Excel formulas. And then finally, of course, you want to get the goal of the problem. So what is the thing you actually want to find? And it's best to just go through line by line collecting this stuff. And then if you do that conscientiously enough, the point is that you will not ever have to do it again. Like no more looking at the paragraph ever. It's good stuff. So, okay, so the deal is that, and I mean, your chart doesn't have to be pretty. That's the other thing about this, is you don't need to make it attractive to the eye. I mean, you might have a whole lot of chicken scratch on the chart as long as it is chicken scratch that makes sense. So for example, this year income consists of amount saved plus amount spent. So what I'm going to do with that is I'm just going to draw two lines. Well, curves, not really lines, like this. And I mean, I'm going to remember at least for 3 minutes what those lines mean. What those lines mean is that those things add up to income. So this is like, these lines are like an Excel formula. I mean, I definitely don't want variables for that, because I don't want, you need to really, really, really watch out for not having excess variables. It's better to just indicate relationships with things like arrows and lines and even words, because having too many variables in the problem is honestly the single thing that makes people get lost on word problems the most. It's a tip there. Just no excess variables. Don't use variables unless you really, really need them. And really, really need them means like I'm about to do algebra with these exact things right now that are in front of me, which we're not doing that yet. So like these lines right here with an arrow on them, that substitutes perfectly well for a variable. It's pretty good. Okay. And there's a fraction. So fractions, we know how those work. So I can just write that in on there too. So income times the fraction saved is equal to amount saved. I can just write that in there too, like that. It's a thing. And then for each dollar that he saves this year, what does that mean? For each dollar that he saves this year, he will have 1 plus R dollars available to spend. What does that mean in terms of math operations? What does this mean for each? So you couldn't write 1 equals 1 plus R, because that would just mean that R is 0. And it's probably pretty clear that R is not supposed to be 0. I mean, you could think about R being 0 as a smart number, as like a pick your own numbers kind of thing. But if you look at these choices, that's not a good choice. Because if R is 0, then A, B, and C are all the same, and D and E are the same. So if you let R be 0, you won't get a unique answer. But yeah, it means for every, that means that it's a ratio, right? Like if I say for every 2 men in the club there are 3 women, that means it's a ratio of 2 to 3. So for every $1 this year, 1 plus R is a ratio of 1 to 1 plus R, which means that you can just multiply this by 1 plus R. So if it was like for every $2, then you'd have to actually do a ratio, but for every $1, that means you just multiply by that amount. So I can draw another arrow with that relationship on it too. So if the money saved this year times 1 plus R along that arrow is going to be the amount that he has available next year. All right. I mean, again, this is not pretty. It's really not pretty at all, but it's functional. It does the job. Also, if I wanted to go the other way, I would just divide by 1 plus R, which I could figure that out, but it also might be worth writing down. Okay. Hold on just a sec. All right, let's keep going through the paragraph. In terms of R, what fraction of his income, so that means this is the goal of the problem, so we should indicate that. So what fraction of his income is the question, so that means that this is the want. So we can write the word want in this box right here too. So that next year, the amount he has available to spend, this green thing will be half of the amount spent. Okay, half of, I don't really like fractions. Instead of saying this is half of this, I can just say this is twice that. So, but whichever way you want to do it, so as long as you are on top of that. So if I take the amount available, then I can multiply it by 2 to get this. Or if I wanted to go the other way around, I could multiply by 1/2 or equivalently divide by 2. So I don't know which way this is going, so I'll just write them both. So that's divided by 2. All right. I mean, this is really not so bad, right? It's because now that we've done this, we are totally done with the problem. Like if the rain came and washed away the problem, that's fine. We don't need it anymore. It's not a thing. It's gone. We don't need it anymore. Cool. So let's solve this thing. Let's do it. How do you want to do it? Let's try doing some algebra. How do you guys want to start this thing? Let's put something somewhere. Notice that the only variable that you really need is R. That might clue you in as far as like you might be able to pick things. But if you don't feel comfortable picking numbers, then what things do you want to pick as variables here? What do you guys think? I mean, one thing we should definitely have a variable for is the thing we want. Because if we're going to have a whole bunch of algebra on the page, we would like to be able to solve for a letter. So the thing that we want, that gets a letter. Let's call that F for fraction. So then if you look at, see if you have all this laid out in front of you, you can see what you actually need and what you don't. Because if I have fraction and income, then if you look at this, what's going on, I mean, that times this is going to be this. And then this is going to be the leftover of that. So I won't need any new quantities for that. And then there's all these relationships among these last things. So if I need another variable at all, I can use one for the income. So let's do that. I mean, notice that I theoretically, I shouldn't even need a variable here. I should be able to just pick a random number for this because there's no I in here. I mean, F is a thing, but I'm solving for F, so that's not why it's in the choices. But if you don't want to think that hard, just call this I. Let's just do it. So then this is the income, and F is the fraction saved. So what's the amount saved? Well, you multiply those. So that's IF. Okay, Now, notice all I have to do is follow my own directions. I just have to look at exactly what I did on the chart. So, okay, well, these two things together make I, and that is IF, and that is the total of I. So what's that? What goes in this column? It's the rest of the income. Yeah, total income. It's total income minus amount saved, right? Because it's just the rest of the total income. Remember, it also has to be dollars, right? This is, if you think about units, it can't just be 1 over F, because F is not a number that has units. So it's dollars total minus dollars saved. So that's I times 1 minus F. The other way that you can figure that out, it's I minus IF. The other way you can figure this out is you can realize that if F is the fraction that you save, then 1 minus F is the fraction that you spend. So you can also express that as your income times that fraction. I mean, those are the same thing, but there's two ways of arriving at that. So, all right, now I just got to follow the arrows here. That's it. The amount saved is IF. If I multiply it by 1 plus R, I get the amount available. So let me just multiply by that by 1 plus R. And then the only thing that I haven't used yet is this relationship. That's not supposed to be opaque. The only thing I haven't used yet is this relationship that's right here. So I would rather use the one that doesn't make fractions, which is that one. So this thing times 2 has to equal this thing. So again, I just follow my own directions. So IF2 times IF1 plus R equals I minus IF. This is an equation. I mean, this is pretty much it, except I have to solve it. What am I solving for? I'm solving for F, so that means I have to distribute stuff and isolate the F's on one side. So 2IF plus 2IFR equals I minus IF. So there's a lot of, and everything has F in it except for that I. So I move the IF over, it's 3IF plus 2IFR equals I. And then to solve for F, let's move this stuff up. I just have to factor F out of that left side. So that gives me F times 3I. Well, F times I times 3 plus 2R equals I. The I's are going to go away when I divide. And that gives me F is 1 over the quantity 3 plus 2R, which is choice E. It's kind of neat. I mean, if you notice this whole workup that we just did here, I mean, the brain work basically stops happening at this step pretty much. You know, like after the variables are in there, there's not really much in the way of brain work. I mean, if you write enough stuff down on your chart, then you kind of just have to follow exactly what you wrote on your own chart, which is kind of neat, really. So you just do what the arrows say. I mean, there was a little bit of thinking required to fill in the amount spent column, but not really a ton. I mean, because I had arrows reminding me that these two things add up to I. So I just had to remember that it was I minus this one, which is, the arrows were there to remind me. So that's a thing. So basically, I didn't have to think at all after I set the chart up. All the thinking is up front. And notice that the rain came and washed away the problem as soon as we were done. But we were okay, because we had this kind of framework going on. So just notice, I mean, again, obviously this problem is hard. I mean, we had the total number of correct answers in the group was a little bit worse than random guessing. It was like 3 out of 16, where random guessing would have been 3 out of 15. So a little bit worse than random guessing. Like, if you just close your eyes and eeny, meeny, miny, mo, it would have been better on average. So that means the problem is hard. But if you look at what makes this a hard problem, you might be surprised. It's just the organization aspect of it. Like, this is really what you have to do to conquer word problems, is focus on these 2 steps. These 2 steps right there. Because if you do these things conscientiously enough, really it's going to be like this problem where there's no brain work after that point, where you just have stuff written down on the chart. And you just follow what it says and you do it. And notice, I mean, I have had people worry about things like this will take too much time. But first of all, not really. It doesn't really take that much time in the first place. You know, to make these columns doesn't take that long, 10, 20, 30 seconds. But it actually takes negative time in the sense that the time that you do spend making these columns, you will easily gain back in terms of not having to keep referring back to the text. Like, if you don't do this, you're going to have to look back at that paragraph like 8 times. And again, it would be foolish to try to finish this in 2 minutes. But after even like 4 or 5 minutes, there were still a lot of people not done, and that indicates a certain lack of efficiency. I mean, nothing wrong with spending 3, 3.5, something like that on a problem like this, because it is a really long paragraph. But there are limits in the world, and 5 minutes is definitely beyond those. Is there any questions about this thing? About this problem? Do type chat box type. Malik is typing question. Let's see what Malik is asking. Any other method bias? So yeah, you can. In the interest of getting to more problems, I'm gonna do this. I'm gonna go ahead and say, like, here's an exercise to try at home. But if you can tell that because I drops out of this problem, and if it didn't, then you would have to mention it in the answer choices. So you can actually pick a number for I, and for R. You can actually pick numbers for both of those, and that might make your life easier. The setup should be the same, though. You should still use the same columns, and you should still write the same sort of stuff down. In fact, let's go ahead and try that. It shouldn't take too long. So let's say that we picked R. So what you should do in a problem that has this many words in it, what's the danger of picking your own numbers? I mean, assuming you're doing a problem where you actually can pick your own numbers. I mean, obviously, if you're doing it when you're not allowed to, that's terrible. But if you're picking your own numbers on a problem, okay, let's see. R, spend the same next year. 1/2 target fraction. 1 2R plus 3. That looks like it works. Okay, so you actually backed into the target fraction. Sure, that approach looks totally valid to me. Then you get, although you would have to try. It looks like you'd have to try all of those different answer choices to see that, which is still doable. Because I noticed in your workup that you have the 2R plus 3 kind of there. So you just have to try them, but if you do it, that's the right kind of, the most important thing that I can say there is just to kind of pat you on the back and say, well, that's the right attitude. In other words, this is the right attitude of, I had to try them all. Because this right here, this is the point where a lot of people would talk themselves out of doing this. Like, a lot of people would look at it and say, I'm not going to do it. I think it's going to take too long. So this is, all that matters is that you did it. So this is good. This is the right attitude. Just throw stuff at the problem and see what sticks. And it'll work. But yeah, you can also, once you have this setup that we have here, you can pick numbers. Like let's say that my income is represented by 1. And then let's say that I let R. So the risk is that you might get a coincidence. You know, like if R is 0, this would be an easier problem, but then A and B and C would all be the same. But if R is 1, so let's try income is 1 and R is 1. So then this would be, let's just see if these numbers are the same. If any of the answer choices are the same, then I'll take a new R. So that's 1/3, that's 1/4, that's 1/5. That's okay, that's bad. That's 1/4 and also 1/5. So nope, don't want R is 1. So let's try R is 2. See, we're checking that because otherwise we would have had to do all that work for that reason, right? So this is 1/4, this is 1/6, this is 1/8, this is 1/5, and this is 1/7. Okay, well that's nice. So then notice that's 1 plus R is 3 now. So, okay, the income is 1, the fraction saved is still F. So the amount saved is 1F. It's probably also a lot easier to see that the amount spent is just 1 minus F now. And then if we follow the black arrow, then this is 3F. And then if we follow the purple arrow, then 3F times 2 is 1 minus F. So 6F is 1 minus F. 7F is 1, so it's E. You can do that too. So the point is, once you have a good physical organization, it's kind of like having a good spreadsheet. I mean, you can do anything with a good spreadsheet. You're not committed to doing things like algebra or whatever. So, yeah, you can pick numbers. You can do stuff. It's cool. And Malik, what you did is basically like back solving type of thing. Neat. All right. So notice the value of doing all this organization work up front. And again, don't talk yourself out of it. That's where you lose this game. Yeah, don't do it. Okay. Why don't we try this data sufficiency? Here's where you find multiple choice answers. Okay, data sufficiency. By the way, we do assume that you guys are familiar with the answer choices for data sufficiency. So if anybody doesn't know what they are, I can post them on the board, but we kind of assume a certain amount of familiarity there. Give it a shot. Okay, we should probably be wrapping this one up pretty soon. Again, if you're not from the United States, you might not have ever seen this before, but we have this guy called Smokey the Bear who reminds you that only you can prevent forest fires. Smokey the Bear also wants to remind you that only you can stop you from doing random work. Shouldn't do random steps, guys. This is really all that time management is, by the way. Time management is just understanding when you are not doing productive things and then stopping. That's all that time management is. You definitely don't have to be fast. Because believe me, if anyone is not fast, that person is me. I am not fast at any of this stuff, but I know why I'm doing what I'm doing when I'm doing it. And if I'm not doing something for a reason, I'm going to stop doing it. I mean, it honestly might be it might be one of the positive aspects of being a fundamentally lazy person is that I don't really do work unless I totally understand the purpose of it. So same thing with doing steps on these problems. You know, if something has no purpose, then I'm not going to do it. but you should have the same attitude towards this stuff. Okay, let's take a look. We are kind of all over the place on this one again. Here's what you guys picked. So you probably realized that mostly realized that it was C or E, but let's just take a look. Let's organize, and then let's start. Again, we don't really need to think about it until we organize. Organizing should happen first. So let's organize. And let me put up that screenshot of things again. Of stuff that you need to be thinking about. Let's put that up there. This thing. Okay. So here's what we had to say about word problems. It's really big. Okay, let's resize that. It's not supposed to be that big. Okay, here's what we need to do when there's a word problem. Let's get this stuff out of the paragraph and let's do the math. I mean, in this case, the paragraph is not as intimidatingly huge. But we should also make sure that we indicate what the goal of the problem is. So what's the stuff in the paragraph? Well, we have these two kinds of books, but there are two aspects of them. There are the count number, and there's the cost. And that is all that is going on in the problem. So we have two kinds of books, and we have count number, and we have, so this seems like a good situation for rows and columns, because these things are for each of two kinds of books, right? So we have hardcover books, and we have paperback books, and we have count times cost, count number times cost equals total money. All right, that's good enough, right? Also, we should make two copies of this chart, because why? Why should we make two copies of this chart? Goal of the problem is the number of hardcover books. Why should we make two copies? Because. Yeah, it's a data sufficiency problem. I mean, remember that data sufficiency is, whenever you say a data sufficiency problem is a problem, that's kind of a lie, because it's actually two problems. Because statement 1 and statement 2 are different problems. I mean, they do happen to be asking the same question, but that's not really, it doesn't make them the same problem. So here are two copies of that chart. Here's one, and here's another one. And I mean, even if you don't need both eventually, and because if you have to combine the statements, you can always import information, or you can just sketch up a new chart. So the goal is that top left box, and then we have what we have. So more than 10. Okay, now when you're working with things that have to be integers, I always find that it helps to translate every inequality into less than or equal to or greater than or equal to, because then you know what the boundaries are, right? So this is a tip that helps me. So it'll probably help you guys too. So translate inequalities into less than or equal to or greater than or equal to. So for instance, more than 10, if you're buying a number of books, means 11 or more. I mean, the reason this helps is because you know the minimum number is 11. Like if you're looking at greater than 10, it's just not that obvious. You have to do a lot more work with your brain to realize that. So this is 11 or more in both statements. So let's just go ahead and write that in there. That is 11 or more, that box that is right there. Okay. And then, all right, so now statement 1, right? the total cost, so that's going to be the sum of, so we can make another ad hoc box here. That money plus that money is a total cost box, which we can put here. This has to be at least 150. Now, I mean, when I'm looking at this, here's what I'm noticing. I'm noticing that I don't have any upper limits at all on anything. Like, if you look at what I have here, this is just a minimum. And this is also just a minimum. And there are no maximums on anything at all. So it should be pretty clear that this is not sufficient. You don't even need to waste your time analyzing it, because you could have millions or billions or trillions. So definitely not sufficient. There's going to be a lot of possibilities for that without even trying. And again, if you write that on there, you can be sure of that. You know, like, this is everything from the problem, and that's it. In fact, remember, the rain could come wash away the problem again here. The rain came and washed the problem away. I don't care. It's enough. Statement 2. Let's see what we've got there. So now we know the total cost was less than 260. So let's just again make this plus this is. No, the total cost, yeah, you're right. So I put that on there wrong. The total hard, yes. Thank you. That's this. So actually, you're right. All right, for statement 1, yeah, okay. So I was going, this is what happens when you go through things too fast. You make mistakes. This is why you don't go through things too fast. Thank you, guys. Yeah, but notice, Fran, you're right, although that's just my mistake, but I don't need to even care, because again, there's still no maximum of anything, right? This is still, so the reasoning of there is no maximum still stands. But thank you guys for being the due diligence police. Okay, so here's the total. This time this really is the total of all the books. This has to be less than 260. I mean, everything here is integers, so that means like 259 or less. Okay. All right, now I have a constraint to work within, so let's see if this does anything. But notice I have no constraint on hardcovers. So let's test cases. Remember, with data sufficiency, you basically have 2 options. Your options are to do textbook type methods or to test cases. In this case, textbook methods are not really going to work, because textbook methods don't work with whole numbers. Because algebra doesn't have any tools for distinguishing whether a number is a whole number or not. So that means that that's not going to work. And we're going to have to test cases. So let's test cases. Well, I mean, in the interest of staying under $260, I mean, let's just make these things really small numbers. So let's say that I have actually 11 paperback books, so that this is $88. Then, this is definitely going to be, you know, if I make 1 hardcover book, then that's going to be $25, and 25 plus 88 is still a really small number. And if it's 2 hardcover books, then it's 50, and that's still small. So this is not sufficient. Okay. It can be, although they're not going to make that matter. Like, the GMAC problems are always written so that wording issues like that become non-issues. So that's another thing that is really cool about the problems that GMAC creates, is they really go out of their way to make sure that tricky wordings are not a thing. So they're going to make that not matter. So Yeah. Because, you know, the problem says he bought some hardcover books. So I wouldn't use 0 just because if you bought some books, then not 0 books. In fact, you might not even use 1 because it says some books. Like, they really do think about that. So if someone is like, well, some books is plural, so I'm going to make it at least 2, it'll still work. But they will definitely still make it work. They're very good about that. So let's do the combination. So if it was my paper, I would just sketch up another chart. So let's do that. The information we have is everything from both statements. So this is still at least 11. This is now at least 150, which means what about the quantity of hardcover books? What does that mean about the quantity? Yeah, it means 150 divided by 6. So this has to be at least 6. Because notice, even if that number was 140, it would still be effectively the same restriction because you have to buy integer units at base. So that's why you want to relate this back. And then this is supposed to stay under 259. So 259 or less. And remember, the goal is to change the yellow number. So what should I do with the not yellow number? What should I do with this number? And again, if you're looking at all this in a chart, it's going to be a lot easier to make these strategic realizations. You don't have to be as smart, so to speak. If you want to change that number, if you want room for this number to grow, what do you have to do with that number? What should I make this? I should make this. Yeah, I'm just going to make it 11 and keep it there. Because keep the minimum number of paperbacks, because we are not interested in changing the number of paperbacks. So that leaves the largest amount of room possible for the number of hardcovers to get bigger. Because that's the only thing we're interested in doing is changing the number of hardcovers. So this is going to be permanently 11, and that's going to be permanently 88, because we're not interested in any other case. So, okay. So let's just take the minimum number of hardcovers. That's 6, that's 150, that's 238. Aha, well, if we try to add another hardcover, that's an extra 25 bucks. That's not going to fly. It's too big. So this is a no-go. Can't do it. I mean, you could add a paperback. In fact, you could even add 2 more paperbacks, but we don't want to because we don't care. So the only number that's possible here is actually 6. So together sufficient. This is C like cat. And again, notice the role played by organization here. It's a big one. I mean, it just helps you keep all the facts straight. Like if you're looking at all these things, then you don't have to remember anything. And if you know that's the goal, then we know we want to minimize that. There's a couple other lessons to be had here as well. Like if you want, you really have to arrange everything around what your goal is. That's another big lesson. You know, the goal is to change the HCs. So thinking about any number of PBs other than 11 is a total waste of our time. And if you didn't realize that, you might waste a bunch of time messing around with different values of these. But any questions about this problem? If you have questions, please type in the chat box. How do we get the, it's from statement 1. If you look at, the hardcover books are $25 each. So if this number is at least 150, then you divide it by 25. Okay, if there are any other questions, please go ahead and ask. If not, go ahead and try that one. Okay, multiple choice options. Wait a minute, here, this one. Okay, multiple choice options are here. Give it a shot. It's data efficiency again. That's Smokey the Bear. Smokey the Bear wants to remind you that only you can stop you from doing random work. If you, this problem shouldn't take forever and ever and ever, amen. I mean, if you are still working at this point, then it seems doubtful that your work is headed towards a distinct goal. I mean, remember, time management is really just a function of honesty with yourself. I mean, that's uncomfortable, but it's the truth. I mean, it's really not a time chart thing. I mean, I think a lot of people bury themselves in things like time charts, almost to avoid the uncomfortable honesty with myself part of time management. But really, it's just, am I doing this work for any reason at all, yes or no? And if the answer is no, then just stop doing the work. But let me give you 15 or 20 more seconds to pick a multiple choice answer. Okay, there's still quite a few of you who have not picked answers yet, but we need to move on with our lines here. Okay, so, I mean, this is sort of a weird way to calculate tips, but don't rush the interpretation part. I mean, so just first ask yourself what's in the problem. So the stuff that's in the problem, you have a bill amount, you have a tip amount, and actually that's really it. So let's make a very primitive chart. Okay, so bill amount, and then let's just say that the tip, okay. I'm going to make columns the tens digit, because it's a thing, the tens digit of the bill. And then so the tip amount. There's my chart. It's not a very pretty chart, this chart. And since I have two statements, I am just going to draw a line down the middle of that so that now I have two charts. How about that? So this is statement 1, and this is statement 2. And if I do have to combine them, I have some room there on the bottom. Now, when you have yes/no questions, we've also talked about this in other study halls. But when you do yes/no questions, let me see if I can pull. Yeah, we've talked about this in previous study halls. Let me give you the quick rundown. When you have yes/no data sufficiency problems, a lot of people don't like these just because they don't make the goals as clear as they should be. Because, I mean, the biggest problem, the biggest issue on yes/no problems is actually the presence of the words yes and no. That's right. That's the problem. Your goal is to get rid of these words. I mean, the reason why these words are an issue is that they're not things. Like, they don't happen in problems. Like, you don't do a bunch of math and then have the words yes and no fall out. It's not really a thing. Right? So what we want to do is we want to replace those with things that are actually things so that we can have goals. So let's take out the word yes and replace that with tip is greater than 15% of the bill. And so you know what else I'm going to do here? I'm going to make a I'm going to make another column for, let me make this compact here. Get rid of yes and no. All right, so I'm going to make another column for the 15% of the bill, because then I can just compare those with my eyes. That's always a good thing. So there we go. And because I know that I am doing inequalities, I'm going to leave a little skinny column there for this sign versus that sign. There we go. So the word no means that the tip is less than or equal to 15% of the bill. So there we go. Okay. And then, I mean, I'm going to write down stuff so that I know what my goals are, right? Like, it's not a very complicated thing, but I'm just going to put each of those signs here with a question mark after it. And then the point is, if I can circle both of those things, then I am not sufficient. And if I can cross one of them off and circle only the other one, then sufficient. I mean, this might seem stupid or overwrought or whatever, but the point is that doing these things will make your life a lot easier. Because suddenly you, at all times, you have goals that you can look at with your eyes. I mean, really, I promise you, you might think this is overkill. But if you make this a habit, if you make a habit of actually writing these things, you'll find that the yes-no questions suddenly become a lot easier. Really, I promise you they will. Just give it a shot. If you make a habit of writing these for all yes-no problems, those problems will get easier. They won't really get easier, but they will certainly seem easier because the confusion will be abated. Okay, now, by the way, let's talk about making a habit of things. If you really want to make something that you are not doing into a habit, what kind of problems should you go do it on first? Where should you go practice something that you want to make a habit? What kind of problems? So maybe that's not really what I had in mind, though. Because those are the ones where it's an issue, so it's going to be extra hard to start it there. Let's say that you were a musician and you wanted to do something. Let's say you wanted to build better habits in the way that you played music, or you just wanted to play the music differently, right? Like, yeah, if you're a musician, if you're going to mess with anything about the way that you play music, you're going to do it on the easiest songs that you play, because those are the easy ones, and you can mess around with them, and you can change things, and you won't get disoriented, right? Whereas if you mess around with anything about something that is already challenging, it's just going to get crazy. So, yeah. Making a habit means go do it on exactly the problems where you do not need to do it. This is why a lot of people are not that good at changing habits, because they try to only do the thing where it's hard and where they need it. I mean, this is the irony, but this means practice it on the easy problems first. This means start practicing it on easy problems. You know, it's kind of like if you live somewhere where there are earthquakes. I mean, if you think about having an earthquake plan, you don't only practice your earthquake plan when the ground is shaking. You know, you practice it on random days when you totally don't need to be doing it, because that's how you build habits. That's what you do. So that when there is stress, you have the habit. It's just a thing. So you should go back and do this kind of organization. And also, this kind of organization. You should go do this kind of stuff on problems where you do not have to do it at all. So that when you get to a crazy problem like this one, then this is a habit and you just do it and all of a sudden, whoa, this is not that hard anymore. But that's the point. Okay, so statement 1. This is everything that's going on in the problem, except for I only have to write this relationship if you double the tens digit. So that's what he does. Let's write that down. Tens digit times 2 is the tip amount. You know, those columns are next to each other. I don't even need to do that. I can just write it in line. So tens digit times 2 equals. There we go. That's cool. And then I don't need the paragraph anymore, and now the paragraph just annoys me. It's gone. I don't need to look at it anymore. Okay, well, so yeah, I mean, you don't have to do these statements in order. The statement 2 is, this is just 8. If this is 8, what does that mean about the tens digit? It means that it's 4. By the way, that means that the answer is not C or E, because these statements are all in statement 1 too. So if you combined these two, you would just get the same thing as statement 2. So C and E pickers, note. Right, because I mean, if it's going to be C or E, then each statement has to have cases that the other one doesn't have. So, yeah, but this means the bill is somewhere in the 40s. Okay, so now notice, I want to make these things both happen. What kind of numbers are generally most expedient at doing this? Like if I want to make something less than and not less than something, I should pick extreme values. I should do that, right? So let's say that the bill amount is like 49. They didn't say it was an integer number of dollars, did they? Did they say that? No, they didn't. Okay, so it could be $49.99. Although I doubt they would make that matter. But let's say that we do $49.99, and then let's say we do $40. Okay, if it's $40, then that's still 4, and that's still 8, and 15% of 40 is 6, and 8 is greater than 6. So then my goal is to make 8 less than something. Maybe I want to make this really big. So $49.99 is the biggest, right? So this is still 4, and this is still 8, but I'm just going to be lazy and take 15% of 50. So this is just going to be a tiny bit less than that. Well, 15% of 50 is $7.50. So this is going to be a little bit less than that. That's still bigger. This is impossible. So it's sufficient. I mean, again, notice that the time that you spend writing those little thingies there, you're going to get it back because you know right away. You're like, I have goals that I can look at with my eyes, and I can circle them, and I can cross them out, and it's so nice. It's so efficient. You'll save the time. Like the time you spend doing these will never really be time spent. It'll be time that you get back at the end. Okay, statement 2 is sufficient. Statement 1. So I know that, I mean, these cases are all in statement 1 as well. So I already have this circled because these numbers are already between 15 and 50. So what is my only goal in life at this point? My only goal in life is to try to do what? To try to get, well, remember the words yes and no are not things in the world anymore. I'm trying to get, what do I want to do with a tip amount? Do I want a tip amount to be like really small relative to the bill or really big? I want the tip to be less, right? So this means, this is my goal, which means I'm going to try. I mean, I only need to look at bills that are something 9.99 at this point, because I want the tip to be less than this, and the tip is not going to change for any tens digit. So if you have a sense of a goal here. So does not 15 and 50, no, that's not the point, right? I mean, I'm wasting my time if I look at any bill that's not 19.99, 29.99, or 39.99 because of the goal. I mean, if I want the tip to be less than 15%, I don't want something that ends with a 0. By the way, between doesn't allow 50 anyway. I mean, it's between means between. Like, for example, Chicago is not between Chicago and Denver. So it's strictly between is the meaning of that word. If they do want those numbers included, they will actually put the word inclusive after the between. So, and if you've ever seen them do that, if you've ever seen them write between A and B inclusive, then that actually is proof that they have to write that, which means that if you don't write that, then it's not inclusive. So let's yeah, I mean let's just try 1999 or yeah. Okay. So then the tens digit is 1 and the tip is 2. 15% of the bill is almost 3. Right, because 15% of 20 is 3. So we got it. It's not sufficient. So yeah. Philippe, I think your 16 will also work because it'll give you 240. Although again, that's not as directed. That happens to work here, but it's kind of a random choice, and random choices are how you burn time on these problems. I mean, you get lucky with that one, but you would want to just check things that look like this because these are your best chance of making this happen. So there you go. It's not sufficient. So overall, this is going to be B like boy. Lindy P, because what we had, like the only thing that we were trying to make happen was this one, right? So if you think about the way these things work, like in each tranche of possible prices, like with the same tens digit, the tip doesn't change. So the best way to get 15% of the bill bigger than a tip is to make the bill as big as it can be for a given tens digit. So, because like all of the bills from 10 to 19.99 are going to have a $2 tip. So we would want, the bigger the bill is within that interval, the better chance it has of doing what we want. So, I mean, Philippe, if you're picking random values, then that's still better than not picking values, because doing stuff is always better than not doing stuff. But yeah, that's probably the result of going too fast through the problem. Don't go too fast through the problem. Also, the other thing, so 2 notes on this, and then we'll quit. We're going over time. Okay, so confusing the ones digit for the tens digit. The first thing is this is probably the result of going too fast. Don't do it. Don't rush. Go slow. The U.S. Marines have a saying, slow is smooth and smooth is fast. The U.S. Marines are correct about that. Okay, the other thing about this is common sense should tell you this is wrong. Because they're not going to define things in a way that is weird or stupid in the real world. Like if someone defined a tip as twice the units digit, just think about how weird that would be. Like they would be tipping the same amount on $81 as they would on $11. you know, that's not how people tip. You know, because the way that Martin tips in this problem is kind of interesting, but it's not a horrible way to tip if you're a really lazy person. I mean, it's a generous way to tip, but it's not that weird. And it does go up as the bill goes up, right? So, and yeah, as Stephanie points out, if the bill is $80, you could be stiffing them completely, right? So, about sharing a link, I was not talking about sharing a link, but in terms of picking numbers, oh no, what I was going to say was I was going to tell you to do it at home. That's all I was going to say. But then we went ahead and did it on the board anyway because we're cool like that. But if you do, there are more study halls on this. There are lots of them. There's like 5 at least. There are lots of study hall recordings with the title Flexible Thinking in Quant or Flexibility. Like if you go to the page with the archive on it, and then Control F or however you find things in your browser, and then search for Flex, you'll find several recordings that you can watch where we talk about different strategies for problems. So you can check that out. It's not just for picking numbers, but it's for lots of alternative methods like back solving, picking numbers, estimation, brute force arithmetic, picking testing cases on data sufficiency. These are all things that people don't do enough of. I mean, I'm going to go ahead and close this pretty soon, but I'm going to leave you guys with a thought. Here's a thought experiment. You walk into the test. You walk into the GMAT administration. On your quant section, the multiple choice problems don't have multiple choices. They just have blanks. And you have to fill them in. But everyone else gets the multiple choices. How would you feel about this? And like, I mean, using your multiple choice answers, A is I'd be mad about this. B is I wouldn't care. How would you feel about this? Actually interested in how people would respond to this. So you don't get the multiple choices, you just have to type the answer into a blank. But everyone else gets the multiple choices. How'd you feel about that? Okay, so most people are saying, wow, I would be really mad, right? I mean, there are a handful of people saying I wouldn't care, but for the most part, you should probably be really mad about that. Because, again, all these things, if you think about why you would be mad, this is the reason why you would be mad. And I mean, what's interesting is there are a lot of people who respond to this with I would be mad, but who don't use these things. I mean, this is the only reason why you would be mad. Because, I mean, if all you did was algebra and textbook methods, you would never need the multiple choices in the first place. So if you're mad, these methods are why. Because this is the only advantage that the other people would have over you, is they would be able to do stuff like this. Not the testing cases part, but, I mean, they would be able to do those 4 things. And the arithmetic. They would be able to do these 3 things, and you would not be able to do them. And that is actually a very big deal. I mean, these things, because of these methods, no, you never get partial credit. The other guys would have an advantage on almost half of all problems. That's a pretty big advantage, guys. So, yeah. And if you did put I don't care, then that means that you are disadvantaging yourself, because that means that you are not using these methods. So these methods are a very, very big deal. You should be using them. They work a lot. If you're not using them at all yet, check out these videos. Okay, we are now way, 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 way over time, so I'm going to kill the recording. Good night, good afternoon, good evening, to wherever you are. Good luck. This is actually the last one of the calendar year. I don't know exactly when the next ones will be, but they'll be in January. It'll happen. It'll be a thing. So we will update you on that as we get it scheduled. It'll post up on the page when it gets scheduled. So look out for that around. I mean, they'll probably post it up pretty soon, I would think, but like before the end of maybe this week or something. Or sorry, before the end of next week. It should be posted up there. So I'm gonna kill the recording, and thanks, guys. Have a good one. Stay safe. If you travel for Christmas, travel safe. And stay warm. And if you're in the southern hemisphere, I'm jealous of you and your heat. And I will talk to you guys in the new year.